let's use this method to do the derivatives of a number of functions. So suppose here we want to take the derivative of f of x equals 7 square root of x to the fifth. The first step here is to rewrite this as a power function. Well, the square root I can write as a 1/2 power. So we have x to the fifth to the 1/2. We can multiply those powers. This will give you 7x to the 5/2. So now I can start taking the derivative. Well, if I want to take the derivative, I can use the constant multiple rule. So I'm just going to take 7, and then I'm going to take the derivative of x to the 5/2. Then I can take the derivative of x to the 5/2 using the power rule. We're going to write the exponent in front, and then we're going to subtract 1 from the exponent. 5/2 minus 1 is 3/2. And then 7 times 5/2 gives you 35/2. So the derivative of this function is 35/2 x to the 3/2. The same thing can be done with the function y equals 4/4th root of x. The first step here is to rewrite this as a power function. The fourth root can be rewritten as an x to the 1/4. When we divide by a power, it's the same thing as making that power negative. So I have 4 times x to the negative 1/4. Now if I want to take the derivative, I can use the constant multiple rule. I'm going to keep the constant in front, 4 there, and I'm going to take the derivative of x to the negative 1/4. When I do that, the exponent will be written in front, negative 1/4 times x. Then I'm going to subtract 1 from negative 1/4. Negative 1/4 minus 1 is negative 5/4. 4 times negative 1/4 is negative 1. So the derivative of this function is negative x to the negative 5/4. Same thing can be done with this more complicated function. G of x is 6/x squared minus 8 square root of x. The first step is to rewrite this all as a power function. X squared on the bottom of the fraction is same as x to the negative 2. Square root of x can be rewritten as x to the 1/2. Then I can take the derivative of this. I'm first going to use the difference rule when taking the derivative, saying I can take the derivative of the 6x to the negative 2 and the 8x to the 1/2 separately. The derivative of 6x to the negative 2 is going to be 6 times the derivative of x to the negative 2 using the constant multiple rule. Then the derivative of 8x to the 1/2 will be 8 times the derivative of x to the 1/2, also using the constant multiple rule. Then I take the derivative of each using the power rule. The derivative of x to the negative 2 is negative 2x to the negative 3. The derivative of x to the 1/2 is 1/2 x to the 1/2 minus 1, which is negative 1/2. Then I simplify and I get negative 12x to the negative 3 minus 4x to the negative 1/2.